So let's talk about valence electrons. So how do I know how many valence electrons I have? So let's first talk about what is a valence electron. So a valence electron is the electron that's on the outside. Okay? So far we've been talking about our shells, like in any, so say we're talking about s orbital, n equals 1, 2, 3, 4, and we have all these electrons. The higher the n, the further they are away from the nucleus. N equals 1, 2, 3, 4, 5, 6, and 7. So if I have an n equals 1 electron, he's here. If I have an n equals 7 electron, he's further away. So the valence electrons are the guys that are on the outside. So whenever we're doing cations or anions or anything that involves removing or adding electrons, we always remove from that outside layer, we add to the outside layer. So the outside, our valence electrons, are what are doing all of it. So if we're saying an electron is doing something, reacting or whatever, it's those valence electrons, those outside electrons. So how do I know how many electrons or how many valence electrons an atom has? Remember, we know how many electrons it has by just looking at the number, and if it's neutral, it has the same number of protons as it does electrons. But I don't want to know just the electrons. I want to know the valence, the outside. So remember we went through and we practiced writing our electron configurations. So if you were to write the electron configuration for, say, lithium, let's talk about writing the shorthand. So the shorthand for lithium would be helium in our brackets, and then 2s1. So what we want to look at is what is after the noble gas. What's after my shorthand? It's just 2s1. Okay? If I did sodium, sodium would be neon, 3s1. So if we notice here, the difference is the N, but they all have only one valence electron. One electron in that outside. So now let's look at the second column, beryllium. We would write his electron configuration as helium, 2s2. Magnesium's would be neon, 3s2. So if we look, how many electrons are on the outside that are written after my noble gas would be 2. So one of the things that we can do is we can look at what column it is on the periodic table. So those that are in column 1 have 1 valence electron. Those in column 2 have 2 valence electrons. Those in column 3, if I did boron, it would be helium, 2s2, 2p1. So I have these electrons that are in the 2. The 2 is my outer energy shell, so I would have a total of 3 electrons in that outer shell. Here I would have a total of 4, 5, 6, 7, and then 8. So if you were to look on a periodic table, these guys have 1 valence, 2, 3, 4, 5, 6, 7, and 8. So the column number on the periodic table will tell me how many valence electrons I have. Okay? But that's only if it's a main group element. If it is a transition element, so if it's in my D block, they will always have 2 valence electrons. All right, so we can practice this to see why it always has only 2. So let's write our electron configuration for, let's see, SC. Right here, number 21. So we pick the noble gas. The noble gas is AR. And then we're here. So AR is my noble gas. Then we're here, 4s1 and 2. And then remember it's a D, so it's 1 less. So 4 to 3, 3d1. So when we talk about valence, it's the guys that are in the outside, the highest n orbital. So because the D's are always n minus 1, all the D electrons are always going to be in a lower orbital compared to the s orbitals. So these s guys are going to be higher. And so I always have the 2 s-or electrons in front of the D's. So that's why all of these transition metals have 2 valence electrons. All right? So now that we've talked about valence electrons, we can move on to the next topic.